f of x is equal to minus 2 x plus 1. And I want to know f of 3. This may be confusing because the base is negative, but the base can be thought of as minus 1 times 2 raised to the x plus 1. So I'm able to get around the non-negative base part of the definition of an exponential function. So if I think of it this way, then I can just substitute this in and not have to worry about problems in the domain that I would if it was negative. So if I substitute this in, this is equal to minus 16. And the thing for me to avoid was the minus base. And that was avoided by thinking of it as a minus 1 times a positive base. Another problem, perhaps related, f of x is equal to 1 minus 3 raised to the minus x, and I want f of 1. And here is another situation where I have a negative and a base, but I can think of it as minus 1 times a positive 3. And then it's okay. But the real issue for me is to remember that the negative exponent will cause this to reciprocate. So when I substitute in 1, f of 1 is equal to 1, and now I'm just going to multiply these together. It doesn't really matter at this point, as long as I already know that I can think of them as two separate things, then I'm alright. Substitute 1 in. Minus 3 to the minus 1. And now I'm going to distribute this minus sign. And a negative power will cause the base to be, will cause it to be the reciprocal of the base. 1 minus 1/3 to the first, which is just 3. So now I'm left with 1 minus 1/3, which is equal to 2/3. And now I'm going to do one more. F of x is equal to 1/4 1 minus 2x. And I want to know f of 3 over 2. magnitude and 3 over 2. What's the base of 1/4 minus 2, 3 over 2. These 2's will cancel each other out. Now I'm left with 1/4 raised to 1 minus 3 to the minus 2. Now I'm going to distribute this minus, which will cause this 1/4 to reciprocate. That'll be equal to 4 to the second, which is 16.